Welcome to this video on the Hartley Oscillator. We will cover the introduction, design, working principle, applications, and the advantages, disadvantages, and frequency range of the Hartley Oscillator. Let's begin with Part 01, Introduction to the Hartley Oscillator. A Hartley oscillator is an electronic oscillator that generates sine waves using an LC circuit. Its primary function is to create a constant frequency signal, which is vital in communication systems. The design of oscillators evolved significantly in the early 20th century. Key figures like Ralph Hartley developed the Hartley Oscillator, laying foundational principles for modern oscillators. Compared to the Colpitts oscillator, the Hartley design uses two inductors. It offers advantages over RC oscillators, such as higher frequency oscillations, better frequency stability, and reduced phase noise, suitable for RF applications. Now let's move on to Part 02, Design of the Hartley Oscillator. Key components include inductors and capacitors, which determine the frequency of oscillation. A transistor or operational amplifier acts as the active component, amplifying the signal and determining the overall gain. The basic circuit layout illustrates how components are interconnected to create oscillations. Variations exist to enhance performance, such as adjusting component values for stability. Design considerations include the quality factor, which is essential for stable output frequency. Component selection is vital for optimal performance, covering criteria for inductors, capacitors, and active devices. We proceed to Part 03, which covers the working principle of the Hartley oscillator. The feedback loop maintains and stabilizes oscillations by returning a portion of the output to the input. The inductor-capacitor network acts as a resonance circuit, determining the frequency of oscillation. The circuit resonates at the frequency where inductive reactance cancels capacitive reactance. The formula shown determines the frequency of oscillation. This slide shows the transfer function derivation for the Hartley oscillator, leading to the frequency of oscillation at resonance. For sustained oscillations, the loop gain must satisfy the condition AV multiplied by beta must be greater than or equal to 1. The formula for the required voltage gain is also shown. Stable oscillation requires adequate gain and phase shift for sustained output. Analyzing waveforms in steady-state operation reveals characteristics like amplitude and frequency. Next is Part 04, Applications of the Hartley Oscillator. Hartley oscillators are fundamental for generating radio frequency signals in communication devices. They are crucial in modulation techniques like AM and FM, enabling efficient long-distance communication. In signal processing, Hartley oscillators are essential for frequency synthesis, providing precise frequencies. They are also used in filter designs to enhance signal clarity and reduce noise. We are now at Part 05, Advantages and Disadvantages. Advantages include the simplicity of design, making it easy to understand. Additionally, it is cost-effective due to affordable materials, fostering hands-on learning. Disadvantages include a potentially limited frequency range, which can restrict advanced applications. The oscillator is also sensitive to component variability, leading to inconsistent performance. Finally, we cover Part 06, Frequency Range of the Hartley Oscillator. The Hartley Oscillator operates across a range of frequencies. Low-frequency applications are found in audio devices and signal processing. High-frequency applications, typically in the MHz range, are used in RF transmission and communication systems. The frequency range is influenced by the values and quality of inductors and capacitors. Environmental factors like temperature and humidity can also affect the oscillator's frequency response and stability. Specific frequency band applications include AM and FM broadcasting for generating stable carrier signals. They also serve as reliable frequency sources in laboratories for experiments and calibration.